Hello, Precalc classes. Sounds like since another snow break is upon us, we need to do some videos to teach you guys because I can't fall too far ahead. It looks like you guys can learn it this way at home anyways. So we're working on analytical trig, and this is section 6.1 in your book, and we're doing inverse trig. So to translate number 8, this is saying, what is the x value at pi over 2? And hopefully you guys all know that that is based off your unit circle, which I have right here. Pi over 2, the x value is 0. So the answer to the first part is 0. And then this part is asking what angle has y value 0? So what angle has y value 0? The first one I come to is 0. So the answer is 0. And there we go. Remember that when we're doing inverse trig, sine and tangent come out of the first and fourth quadrant, but not exactly. It's from negative pi over 2 to pi over 2. And cosine, which I tried to write in red, goes from 0 to pi. It's in the top two quadrants because x would be positive and negative there, and sine would be positive on top and on bottom. So just remember that as we are doing these trig problems. Okay. So here we go with the next one. Inverse tan is basically saying what angle has slope -1. So slope -1 would have to be in the pi over 4 family because that is where the coordinates are the same. And so the slope being -1 would come out of this quadrant. And I can't say 7 pi over 4 like everyone would like to say. I have to say that it is down pi over 4. It is a negative pi over 4 for my answer, because we can only give answers from negative pi over 2 to pi over 2. Next question. This translates into what angle has y value -√3 over 2? Again, you guys must know your unit circle, but if we were to look at the unit circle, we would see that it would be this angle right here. That's where my y value is -√3 over 2, which again, I cannot say is 5 pi over 3, because that would be implying that I'd be going all the way around to 5 pi over 3. Instead, I just want the one closest to 0, which is a negative pi over 3, right? It's just down pi over 3. So the answer to that would be negative pi over 3. I can't write in this. There we go. All right, next one. Inverse cosine. Again, remember that cosine comes from the top of the unit circle from 0 to pi. So where is the x value -√3 over 2? It's right here at 5 pi over 6. And 5 pi over 6 is less than pi, so that is perfect. 5 pi over 6 is the answer to that one. Here we go. Hardest one of all, or so I think. Inverse tan of √3 over 3. So when I see √3 over 3, the first thing we have to realize is that that has been rationalized. And before it was fixed, that fraction was 1 over √3. So I'm looking for a coordinate on the unit circle where the y value is a 1 and the x value is a √3. And I know that they're positive, so I know I'm in the first quadrant. And to find a coordinate where the y value is 1 and the x value is a √3 is right here at pi over 6. And again, I'm not bothering to say 30 degrees because we're talking with everything in radians at this point. We're talking about graphs, and if we're talking about graphing something, we cannot do our x-axis in degree measures. It would have to be in radians, right? So that's the other reason why we're talking in radians. Okay, hopefully that makes sense. Let's try another one. Does inverse sine of the sine of 2 pi over 3 equal 2 pi over 3? This is number 46 in your book. I'm just going through a bunch of your homework problems from section 6.1. So, well, let's think about this. The sine of 2 pi over 3. First of all, if I'm talking about 2 pi over 3, I'm not exactly in the right quadrant for inverse sine, right? If I'm saying sine of 2 pi over 3, here's 2 pi over 3, and my sine or y value is √3 over 2. So the answer for that part is √3 over 2. So now I'm asking inverse sine of root 3 over 2. In other words, what angle has y value root 3 over 2? And I can't go over here to this quadrant to answer an inverse sine problem. I have to take it from over here. So where's the y value root 3 over 2? It's at pi over 3. So the answer to this is pi over 3, not 2 pi over 3. So I guess the answer to this is no. Pi over 3 is in the correct quadrant for inverse sine. All right, so here's our next one. Inverse cosine of cosine of negative pi over 6. Again, remembering that inverse cosine should come from 0 to pi, and negative pi over 6 is down here. So again, it's in the wrong quadrant. So the first thing I need to think is that pi over 6, my coordinates are root 3 over 2, 1/2. So the x value is root 3 over 2. And then I have to think what angle has x value root 3 over 2 from these quadrants. Well, that's up here at a positive pi over 6. So this one is a big fat no again. Right? I cannot take negative pi over 6 for inverse cosine. Inverse cosine has to come out of the top. So that would be up here at pi over 6. All right, trying the next one. Inverse cosine of 2 pi over 3. So the first thing we do is figure out where 2 pi over 3 is. Well, 2/3 pi is less than pi, so it must be on the top of the unit circle, right? 2/3 pi would be up here in the range we want it to be in. So first I'd have to say, what's the x value there? Well, the x value there is negative 1/2. And then it's saying what angle has that x value? Well, I'm allowed to talk about inverse cosine from there. So that is correct. That is yes. How about this one? If I start inside the bracket, it's saying what angle has x value 2? And again, since all of this is based on the unit circle, that doesn't make any sense because the biggest x value on the unit circle is 1. So I'm already done right here. Not possible. So this is no. And last but not least from this section, tangent of 2 pi over 3. Again, 2 pi over 3 is up here. And if it's in the 60s family, then I know my coordinates are 1/2 root 3 over 2. But I know in this quadrant it's a negative 1/2 root 3 over 2. So if we're talking about tangent, I'd ask for the y over the x. So that would be root 3 over negative 1. That's the answer to this part. So now I'm asking what angle has tangent negative root 3 over 1. And again, remember that inverse tan can only come out of these two quadrants. So I cannot look back at 2 pi over 3. So this is a big fat no. But let's figure out what the actual answer is. So if I know that my y value is a root 3 and my x value is a 1, if I look up here, y value is a root 3, x value is a 1, that's here at 5 pi over 3. But I can't say 5 pi over 3. I have to say the one closest to 0, which would be a negative pi over 3. So the answer to this should be negative pi over 3. And that was a bunch of problems from section 6.1 and hopefully helpful for your review.